Hello, today I'm going to present to you properties tables. That is going to be one of your best ally, one of your best resource, one of your best tool in this class to have good grades. So you may ask, what are properties tables? So I'm going to give you a little background to introduce you so you may well understand. So for many substances, the link between thermodynamic properties are too complicated to describe with simple formulas. Because of this complexity, these properties are often provided in tabulated form. Some properties are easy to measure directly, while others must be determined through their relationship with measurable quantities. The outcomes of these measurements and calculations are organized and presented in tables for easy use. So the property tables list the thermodynamic properties of a pure substance at various temperatures and pressures. They are going to provide the numerical values for four specific thermodynamic properties, which are specific volume, specific internal energy, specific enthalpy, and specific entropy. These four specific thermodynamic properties, they're going to be very important in this class. So they're going to provide these numerical values for three different phases: saturated, superheated, and compressed. And for this course, the pure substance we're going to encounter in our exercise is going to be water and the refrigerant 134A. So now you may ask, what are these three different phases? The first one is called the saturated phase. It's a state where a liquid and vapor can coexist in equilibrium. They're saturated liquid when it's basically saturated, which means it cannot hold more energy. If it holds more energy, it's going to change phase and it's going to boil. Saturated vapor is the same principle. It's saturated. It can't hold more energy. So when it has more energy, it's going to change phase. It is going to condense. The second phase is superheated. It's a vapor that is heated above its saturation temperature at a given pressure. It's 100% vapor. The temperature is higher than the saturated temperature for a certain pressure, like we said. And now for this phase, temperature and pressure, they become independent, whereas the saturated phase, they are dependent, temperature and pressure. The final phase, it's the compressed phase, also known as subcooled. It's a liquid at a pressure higher than the saturation pressure for the given temperature. It's 100% liquid. Like we said, pressure is higher than the saturated pressure for a certain temperature. And temperature and pressure, they become independent also. Now, finally, how can we choose the right table? So, when we have an exercise and we want to find our thermodynamic properties in our table, we need to look for first of all the right substance, but this is easy because it's always written in the problem. But we also need to find the right phase, the right three phase. So how do we know? It's pretty easy. I'm going to show you. So if your specific volume is lower than the specific volume of gas and higher than the specific volume of fluid, you know you're in the saturated table. If it's higher than the specific volume of the gas, it's for the superheated table. If it's lower than the specific volume of the fluid, it's in the compressed table. So you see, for the superheated, we operate with gas, and compressed, we operate with fluid. Because superheated is vapor, compressed is liquid. It's logical. You can keep that in mind. So now, for temperature, superheated, which means higher temperature. When it's higher than the saturated temperature, we are in the superheated. When it's lower, it's compressed. So it's the opposite. Now for pressure, when it's compressed, it has more pressure. So if it's higher than the saturated pressure, we need to look our thermodynamics in the compressed table. And for superheated, it's the opposite. So now you know what thermodynamic properties are. You know what are the three phases that we find in the thermodynamic table, and now you know how to choose, when you do your exercise, the right table to find the thermodynamic properties. So now you have all the tools to have an A in the thermodynamic class. Thank you for listening.